Okay? So, as I've said earlier, if you're going to use your calculator and you are dealing with a pi, then you set the mode into rad because ang calculator ay usually naka-degree ang kanyang mode. So, you set that into rad and then you just key in tangent pi over 4 plus sine pi over 4 and that answer would be 1.7. Or if you're going to recall our um, in degrees, pi is equal to how many degrees? That is 180. So, if your calculator is in degree mode, if your calculator is in degree mode, so pi is equal to 180. So, if you're going to get for tangent pi over 4, then you will be getting tangent 180 over 4 and that is tangent what? Tangent 180 over 4 is equal to 45. So that's tangent 45 degrees. So you will have the same answer. In a unit circle also, ayan, you just have a review. So if this is that is 0 and this is pi and this is 2 pi, okay. So this one is pi over what? Pi over 2. And this is 3 over 2 pi. So, pi over 4 is kalahati ng pi over 2. And this is actually 45 degrees. Alright? So, okay. So, I have here, getting these values of tangent pi over 4 and sine pi over 4. So, we have 1.7. Okay, so in solving for the functions, we have indeterminate forms and other methods of solving for limits, for solving limits rather. If we directly solve limit of the given function, we have a given function square root of x squared minus 9 over x minus 3. And if we immediately substitute the value of x being approached, that is 3, then we will have a 0 over 0. If that is the case, then we have an indeterminate answer. So solving for this involves three of the methods. We can apply the rules of limits by simplifying first the given function, or we can apply the L'Hospital's rule, which will apply the knowledge on derivatives, or we can apply the Gilisania's principle. So, in the example, a limit of, say, x cubed minus 64 over x squared minus 16 as x approaches 4. So, we're going to find the limit of this function as x approaches 4. So, by using method 1, we just simplify and applying the rules of limits. So, we have limit of x cubed minus 64. And how do we simplify this one? We factor out. So, the factor of this is x minus 4 times x squared plus 4x plus 16 all over x squared minus 16. So, x squared minus 16 is a perfect square. And so, that's an x minus 4, a factor of x minus 4 and x plus 4. So, if we are going to observe this one, so we can cancel out like terms. So, we have x minus 4. We can cancel this, or we can convert that into a value of 1. So, we can cancel that out or convert to value of 1, and that will be equal to 1. So, what remains is this one, just x squared plus 4x plus 16 over x plus 4. And substituting x is equals to 4. So we have 4 squared plus 4 times 4 plus 16 over 4 plus 4. And so we have an answer of 48 over 8, and that is 6. Okay? So for the method 2, we have the L'Hospital's rule. Ayan. If you have knowledge on derivative already, you can answer this one, but we will discuss this further after we have discussed about the derivative. For the method 3, we have the Gilesania's principle. And so what we will do is just we assume a value that is closer to the value being approached. Since that is just approaching, then that means that hindi siya equal talaga sa 4. So that is near to 4. So if we have 4 as the value being approached, we let x be 3.99 or 4.001, and then we just directly substitute this value to the given function, such that we have a 3.9999 cubed minus 64 over 3.999 squared minus 16, and so we have an answer of 5.99, round off to 6. So if you have a value of 2, then you just substitute negative 1.99 or 2.001. And if you have a value of infinity, that's a large number, then you substitute 999999. That's a large number. So you will come up with the same answer. So if your answer here in Gilesania's principle and using simplifying by using the and applying the rules, then your answer is correct. So now we move to continuity, and what is a function is said to be continuous if the limit of that function at a certain value is not infinity. So it can be determined. So we have the limit of f of x as x approaches a is actually f of a. And f of a here is being defined, and the limit exists, and the limit is also equal to the function of a. And that is the function of the value being approached. So we have here examples of continuity and discontinuity. So for letter A, f of x, x squared is continuous at any value of x. So kahit anong value ang ilagay mo dyan, still meron siyang mailalagay na, meron siyang given na range. So if you have f of 2, that is equals to 4, f of 4, that is equals to 16, and then as a matter of fact, this function is actually a parabola opening upward if you're going to recall this function f of x is equals to x squared. On the other hand, f of x is equals to 1 over x is discontinuous at x that is continuous rather at x greater than 0 and x that is less than 0. But this is discontinuous at x equal to 0. Why? Because if we're going to get for the limit of 1 over x as x approaches 0, then the answer will be an infinity. So if the answer for the limit of the function is an infinity, then that means that the function is discontinuous at a certain point. In fact, this function is a hyperbola with asymptotes. Okay? So for another example, we find the points of discontinuity. We find the points of discontinuity at which the function is discontinuous. So if we have a given function, say f of x is equals to 3x over x minus 5, the function is discontinuous if the limit is infinity. And when the limit is infinity, then the denominator must be equal to 0. And thus, x minus 5 should be equal to 0. So the function is discontinuous at x equals to 5. How about this one? So we have 5x plus 5 over x squared plus 4. So we just equate this into 0. So we have x squared is equals to negative 4. And x is equals to square root of negative 4, and we all know that the imaginary value does not exist, and so this means that the function is continuous at all points. So by analysis also, any number being squared, so we have x squared here, produces a certain value. So whether and that is either whether it's a positive or the negative, it produces a value, and so the denominator in this case can never be equal to 0. Okay, so we're done. So you now answer the exercise number 2 for the limits and continuity. All right. So that would be all. Thank you very much.